All right, in this lesson, we are going to take a look at a way of expressing sums, and we're going to use this Greek letter called sigma that you may have heard about, or you may have heard it before, or you may not have seen it. But sigma is used to represent a sum in math. So whenever you see this symbol right here, it's kind of goofy looking symbol right here. You see it here. Okay, you see it here. That is the Greek letter sigma, and it represents a sum. A sum of what? Well, it's a sum of an expression with different numbers plugged into it. So this is kind of how it works. You're going to be given sigma right here with a number below it and a number above it. The number below is the number you start plugging in, and the number at the top is the number you stop plugging in. So see how it says k equals 1? That means the first number you're going to plug into the expression is 1. Right here to the right of sigma, you're going to see the expression, 3k plus 7. It says k equals 1. So obviously you plug in 1. 3 times 1 plus 7. That's pretty easy. But you don't just plug in 1. You plug in every single integer, every number, from 1 all the way up to 5. You start at 1 and you go to 5. So we're going to show you I'm going to show you here how to evaluate sigma from 1 to 5 of 3k plus 7. That's how you read that. Okay, so the sum from 1 to 5 of 3k plus 7. So we start by plugging in 1. So it's going to be 3k, which is 1, so 3 times 1 plus 7. Okay? That's plugging in 1 to our expression. Now we move up. What comes after 1? 2. So now we plug in 2. 3 times 2 plus 7. And we're going to add those expressions together. Add those values together, I should say. Plus. Why are we adding? Because that's what sigma tells us to do. Sigma means add. Okay, it's a sum. That's the universal symbol for sum, for adding. Okay, so now it's going to be 3 times 3 plus 7, and then 3 times 4 plus 7, and then 3 times 5 plus 7. And that's where we stop, because we got to 5. As soon as we get to 5, we stop plugging in, and that's going to be our sum. And then you just simply calculate it. So this is 3 plus 7, which is 10. 6 plus 7, 13. 9 plus 7, 16. 12 plus 7, 19. 15 plus 7, 22. And you add all those up, and it comes out to be 80. I did it ahead of time just to save you time. You add those numbers up and you get 80. It's pretty simple. We're just going to do a couple more, and then we're going to set up a couple where they give you the sequence and you have to come up with sigma. All right. Now this one here, you'll notice a little difference. There's a little 2 in front of the sigma. There's an invisible times symbol, just like any time you wouldn't see an operation symbol. It means 2 times. So this is going to be 2 times. We're going to put a bracket just because I still have to have parentheses to add everything up. So I'm going to put a bracket just to kind of symbolize to do it at the end. We're going to worry about the 2 at the end. We're going to worry about this right now, and then we'll do the 2 at the end, okay? So plug in 4, 5 times 4, plus, now plug in the next number, 5. 5 times 5. See how it's 5k? 5 times 6. Plus 5 times 7, plus 5 times 8, plus 5 times 9, plus 5 times 10. That's a 10. Close the bracket. So now I do all the addition first, then multiply by 2. So it's 2 times, and that's going to be what? 20 plus 25 plus 30 plus 35 plus 40 plus 45 plus 50. So it ends up being 2 times 245 and that comes out to be 490. All right, so 490 would be our final answer there. Is that right? 95, 135, yeah, 170, yeah, okay. I just want to make sure I doubled it. All right, and this one here is, we're going to do one more here. So now it's P, the expression is P times 3 raised to the P. So and your P is 1. You start with P equals 1. Now see how you got a 4 plus here? Very important that you do that at the end. So it's 4 plus, instead of times, it's plus. Don't worry about the 4 plus. Do that at the end. 4 plus what? Well, we plug in 1. So it'll be 1 times 3 to the 1. Plus, now go up to 2. 2 times 3 to the 2. And now go to 3. 3 times 3 to the 3rd. All right, that's it. So we'll do 4 plus, and that's going to be 4. So it's going to be 3 plus 18 plus 81. And that's going to be, you add them all up, you're going to get 106. And that's that. Now, when they give you the sum, and now you got to use sigma notation, you just got to look for pattern. What's the pattern? So I'm going to write my sigma, because I know I'm going to do that. And if you can go from 1, I'm just going to use n. n equals 1. If you can start with n equals 1, it'll make it easier to write the expression. You could start at any number you want, though. You can always adjust, and there's more than one answer. There's not only one way to write this. You may come up with a different sigma than I might come up with, and that's okay, as long as it works. So now, what's happening here? Well, the 4, see how it's all raised to the 4th? The 4 is the constant. It's always staying raised to the 4th. So I know whatever I put here has to be raised to the 4th. What's happening in the base is it's increasing by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. But naturally, you're going to automatically increase by 1. Because you're starting at 1, you're starting at 1 here, and then you're automatically going to keep adding 1, because that's what you do when you do summation. So you're going to go up 1, go up 1, go up 1. You're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 anyways. So we're going to just call it n. We're just going to call the base n, and then to the 4th. And we'll stop at 9. Now, what I want you to do is test out why this works. Because it's the first one you might be like, whoa, where did he get that from? But just, you'll see what I'm talking about once you plug it in. So to check it, so this is just a check, to make sure we're right, start at 1 and plug it in. 1 to the 4th. See? Now what comes after 1? 2. All right. Plus 2 to the 4th. Yep. That matches. That matches. Okay, now plug in the next number. What comes after 2? 3. 3 to the 4th. 3 to the 4th. See? That matches. So on and so forth. That is creating that sigma. Now, I stop at 9 because 9 is the last number that I want to plug in. All right, so that does work. So it does check, and that is my answer right there. Don't cross off the 1. And last one here. Half plus 2/3 plus 3/4 plus da-da-da-da-da plus 99 over 100. All that just means keep going until you get to 99, keep going until you get to 100. So the pattern is we're increasing by 1 on top, we're increasing by 1 on the bottom, but naturally that's what it's going to do when you plug in, starting with 1, it's going to automatically do that anyways. And the bottom number is 1 less than the top. The bottom number is 1 more than the top number, or you could say the top number is 1 less than the bottom. So there's a couple ways to do this. You could say sigma 1 to 99, and it'll be n over n plus 1. Because, and you can put that in parentheses if you want, because now you plug in 1 and you plug in 1, 1 plus 1 is 2, you'll get 1/2. You plug in 2, you plug in 2 plus 1, 2 over 3. All right, so that works. Or you could do it like this. And there's also more answers than this. You could start at 2 you could start at 2 and call n the bottom number, and then this would be n minus 1. See? And then go to 100. See, these are both, I'll just put or. These are both the same exact thing. Test it out. Plug in a 2, right? 2, it'll be 1 over 2. Plug in a 3, it'll be 2 over 3. Plug in a 4, it'll be 3 over 4, and so on and so forth. Plug in 100, it'll be 99 over 100, which is the last number you want. Then you would stop at plugging in 100. So that's how you would get that. You just got to look for patterns. Know that they automatically increase. Each sequence increases by 1 anyways. So if it's already doing that, that's all you're going to do. And we wouldn't expect you to have to do anything much harder than that. All right, so I will see you in class for practice on this tomorrow.